Hello students. The objective for today's lesson is to convert from exponential to logarithm and from logarithm back to exponential. A logarithm is the inverse of the exponential function. So a lot of the times students will see the word logarithm and they've never seen it before. They get concerned. But a logarithm is just another way to write an exponent. Okay, so today we're just converting from exponential to log and back from log to exponential. The standard form you need to know for logarithms is y equals log base b of x. So say that to yourself, log base b of x. That is the proper way to say this expression. B is going to be your base. So think about where your base is in an exponent. It's what is being raised to the power. Y is going to be your exponent. And x is what your exponential expression is set equal to. The common log is when the log has a base of 10. So just like in exponents, if there's not an exponent written, we assume that exponent is 1. Well, in logs, if there is not a base written, then we assume that the base is 10. It's a terrible looking 10. In other words, if it does not have a base written, we assume the base is 10. Okay, so I just said that. So let's look at how we're going to convert back and forth. So here's our log expression. Log base b of x equals y. We're going to convert this to look like an exponent. Now to do this, I call this the swirl. We're going to swirl around the log expression to get it as an exponent. So we're always going to start with our base, which is b. So we're going to say b to the y power. So let's write that down. B to the y power equals, so we're going to pick up our equal sign and set it equal to x. Okay, so this is called the log swirl. Some people call this the log smiley face or something like that because it does look like a smiley face. But just remember, you will always start with your b and then you will swirl your way around. Okay, so let's look at this first set of examples. We're going to convert these logs to exponential form. So again, we're going to do the swirl. So we're going to start with our 6. We're going to swirl around to get our exponent of 3. So 6 to the third power. Pick up your equal sign. It's equal to 213. Now, after you have converted it to exponential form, go ahead and check that with your calculator and make sure it is a true statement. You know that you've done it correct if it is a true statement, and 6 to the third is 213. So let's move on to the next one. We're going to swirl around. Always start with your base, 27 to the 1/3 power. So let's write that down. We're going to pick up our equal sign, and that's equal to 3. And that is a true statement, so you know you did it correct. Okay, pause the video right here, do number 3 and 4 on your own, and then play it back when you're ready to check your answers. Okay, here's the answers to number 3 and 4. Hopefully you got these right. 5 to the negative 2 equals 1 over 25. Now remember, you could probably check this in your head because we just talked about negative exponents and that makes you flip it. So it'd be 1 over 5 squared, and 5 squared is 25. So we know the correct answer is 1 over 25. Now in number 4, hopefully you got this right. There was no base there, and so we assume that the base is 10. So 10 to the second power equals 100, and that is a true statement, so you know you got it right. Okay, so let's look at this next set of examples. Now we're going to work backwards. So we're going to start in exponential form, and we're going to work backwards to get it into log form. But let's look at how to do that. We're still going to swirl around the exponential form. So we're going to start with our base b. Well, first of all, you're going to start by writing the word log. Then we're going to start with our base b of x equals, and then y. So let's start with number 5. First thing you do is write down the word log. If you're going to convert to log, you have to have the word log written. And then you're going to start with your base. My base is 3 of 81. So the 3 is going to be a subscript. The 81 is going to be regular. And we're going to pick up our equal sign and then set it equal to 4. Okay, let's move on to number 6. Start with the word log. Base 8 of 1. Pick up your equal sign, and it's equal to 0. Now this is actually one of our log rules, and I will write this down in just a moment. Pause the video right here for number 7 and 8. Let's do those on your own, and then play it back when you're ready to check your answers. Okay, so hopefully you got number 7 and 8 right. I just want to point out one thing. On number 7, we had a base of 10. And so I first wrote it down with a base of 10. But if you remember, your base 10 is your common log. So you don't have to include the base 10. And you can just write log of 1 over 100 equals -2. And then on number 8, you had log base 4 of 64, and that equals 3. So hopefully you got those right. Again, this lesson is just about converting from logs to exponents and exponents to logs, so you're just going to have to remember to do that swirl. Okay, let's go back and talk about number 6 for a second. This is a log property, and so I'm gonna talk about it for just a second. The log property says that anytime you have a log base b of 1, this will always equal 0. And I hope that you can understand why by looking at number 6. Let's look at number 6 again. It says 8 to the 0 equals 1. Well, so why is it that when we convert it to a log base 8 of 1, that it will equal 0? Well, it's all based off of the exponent. Anything to the 0 power is equal to 1. So it doesn't matter what your base is. If you have log base b of 1, it will always equal 0, because anything to the 0 power is equal to 1. Okay, so this is one of your log properties, and it will be helpful to remember this property. If you don't remember the property, you can just always convert it back to exponent, and hopefully you can get the correct answer. But if you, again, properties are just there to make it easier for you. So this is a property that you can memorize. Okay, so I hope that you learned this lesson well, and we will see you tomorrow as we start to apply this in our classroom.